Okay, so we're going to be continuing on looking at Module 5. I will say Module 5 is probably the most important module, or the even equilibrium of rigid bodies is the most important subject of statics. It really is, as we look at statics problems, it's like what you have to do for everything. And so as you go forward, you're going to be using this in strength materials, machine design elements, when you guys do your when you guys do dynamics, you're going to be using it in there too. So this is something that's really a subject that we have to get to know. So we're going to continue on here. I'm just going to revisit our learning plan. As you know, we're in chapter 4. This is the McGraw-Hill ebook. So we're back in the ebook for this module. And I do have the guided notes here. We started this, I'm going to say about halfway done the last time that we were together. So we're going to continue on through the rest of the problems here this evening, which will then set you up for your application problems. So what I'm going to do is I'm going to go underneath our camera here. We are going to be skipping one of the sample problems. So on page 7 here, you can just cross this out. We're not going to be doing that problem. I decided against it. And instead, we're gonna skip over to page 8, and we're going to be looking at problem 411. Problem 411. Now, 411 is found on page 176. These are the problems in the blue section in that ebook, okay? I just have mine printed out, so I have it here. And we're going to look at this problem right here on the left-hand side, okay? So problem 411 says, for the frame loaded as shown over on the left-hand side here, determine the reactions at A and at E. So A is up here and E is down here. So what we're going to do is we're just going to do part A here, and we're going to look at alpha, this surface right here, the angle of that surface is 30 degrees. We're not going to do part B. We're not going to do it twice. So we're just going to do it once, just part A for 30 degrees. So I'm going to start by creating our free body diagram and then just kind of identifying the things that we know that we need to do. So let me see here. I'm trying to find my tractor. Here it is, my desk. Okay, so I'm gonna make sure I put my convention up in the upper right-hand corner. And now I'm gonna draw the free body diagram. So I'm gonna start up where A is, okay, in that upper left-hand corner. And I'm gonna make it, as you know, always make it large enough so that we can, make notes and such. I'm gonna kind of come over to here. A is kind of gonna be here, so I'm gonna come down there, and I'm gonna draw. Now again, this doesn't have to be, scaled out, but proportionally, you want to kind of have it where it's supposed to be. Okay, and then this angle is going to be 30 degrees. Okay. And then we're going to have E coming right there, okay? Here. A is going to be up here. And then we've got this called out as corner D. This is corner C, B. And then I'm going to add in the forces that we have here. So I kind of just did the perimeter here right now and identified each one of those points. I'm going to add in the 20 pounds going down at B and the 20 pounds going to the left at C. Now I'm going to add my dimensions in. So from A to B, this is 10 inches. The distance from B to C, right here, okay, this distance is 3 inches. And then vertically down to C is also 3 inches. Doesn't look like a 45-degree angle, but that's what it is. And then from C to D is 5 inches. And this is point, put it here, I think that'll work. From E to D is 8 inches. And I think those are all the dimensions that were given. Okay. Now, A and E are our supports. Okay. So we're going to look back at the figure that was given to us. Let's look at A first. Now, A, you'll notice, has kind of this, little point in the middle, and it looks like what type of a support. If you remember from page 160, I'll pull that out. Page 160, when we look at the different types of popular supports that we are going to see, we had rollers, rockers, frictionless surfaces, cables and links, pins, rough surface, and then also a fixed support. Do any of these seem like they would fit with what A looks like? Any ideas? And I'll open up the chat box and in case anybody wants to put it in there. Or you can verbally just say it.
A regular support.
Which one is a regular support?
Let's see. It says
Is it the top one?
no, I mean the pins.
Oh, the pins. Yes, exactly. It is
That's what I
going to
meant.
be a pin support. Whenever we have a pin support, we are going to have two reactions, an X and a Y. Okay. So we are going to put at A an X reaction and a Y reaction. And as I look at this, I'm not exactly sure. I'm going to be honest. And I don't know. So I am going to simply put in here a Y. Okay. So I'm going to call this a Y. And then I'm going to call this AX. And I'm going to put it going to the right. As we had learned the last time we were together, we assume a direction. And then we are going to find out in our final answer if it ends up positive, if we assume the right direction. If it doesn't end up positive and ends up negative, then we've got to make it right. And we just have to switch it around. So, but we are going to put it there. We know it's a pin, so it has an X and a Y reaction. And we're just going to assume a couple directions. As we look at E, okay, E, this one might be a little bit more obvious, looks like that. So if I pull in my options here from page 60, any ideas which ones that would apply to?
Roller.
Looks like a roller, right? And that's going to be one force as a reaction, and it's going to be perpendicular to the surface it's riding on. So in this case, it's riding on that surface that's at a 30-degree angle. So that means that we're going to be showing one force perpendicular to that surface, okay? Not along the line. The surface is at that 30-degree angle. So this is going to be our force E, okay? Now, as you can imagine, because force E is at an angle, we're going to have to break it into its components in order to find its value. So we are going to have a Y component here. So this is going to be EY. And we are going to have an X component. This is going to be EX. Now, if you're not sure which way E is going to go, okay, and I'm not, it could point towards or it could point away. Just make sure that your X and Y components go along with whatever direction you've chosen. So I like to say it out loud and say, oh, I have my E going up and to the right. That means that my Y has to go up and my X has to go to the right. So I'm going to assume that direction for right now. And again, even if I'm wrong, I will figure that out a little bit later, but at least I have the right amount of supports that are needed, okay? So as we look here, we have everything on here that we need in terms of, what was given in that figure, the two applied loads, and then the two supports and the reactions identified here. So step one is always our free body diagram, right, in our convention. So step two, just like it has been for many of our problems, is going to be any component work that we need to do. And we do. We need to break E into its X and Y components, right? So go ahead and do that. Figure out what the X and Y components are going to be for E. I'm going to let you work that out a little bit, okay? And make sure that you get on the right track. Make sure you have your angles in the right place. Did everybody get the same values for the components that I did? Any questions about that? So if this is a 60-degree angle from horizontal, which is the same in both places here, well, that means from the X or from the horizontal, it's going to be then 60 degrees to E and then 30 here. Since this is the angle 60 right there, if we take the hypotenuse of E and the side adjacent, that's the cosine of 60 for the X. And then for the side opposite would be the sine of 60 for the Y. Notice that we had to put the X and Y components in terms of their hypotenuse so that then we'll be able to solve for that a little bit later. Okay. We don't know E's value yet. Right. Okay. All right. Any questions so far? All right. Then tell me what we're going to do next. Or 3. What is our next step here? Equations of equilibrium? Yeah. So we're going to use our equations of equilibrium. To see how far we can get there. Okay. So let's do the sum of the forces in the X direction equal to 0. Remember, equilibrium means that everything is in balance. So we set our forces, in this case, in the X direction, we'll start there, to 0. There are two sides of the equation, so we're going to sum our forces on the left-hand side and then set them equal to 0. So we're going to be looking now at only horizontal forces. So you're going to notice that we have an AX positive, so I'm going to start there. AX. And then I have a 20 pounds going to the left. So according to our convention, that would be a negative 20 pounds. Make sure you keep your units in the problem. And then as far as X component here, we assumed a positive direction for EX. Now, EX right now is going to be, we're going to put it in terms of E. So this is going to be minus or plus 0.5 E. Okay. And those are all the forces in the x direction. So we're going to say equal to 0. Now, I'm going to move my 20 to the other side. So I have AX plus, 0.5E is equal to 20 pounds. All right. But I've got two unknowns here, so that's as far as I can go. Okay. So let's try our next equation of equilibrium. Let's try sum the forces in the y equals 0. Okay. So if we sum the forces in the y here, we're going to look just at vertical forces this time. So now we're going to say, all right, AY going up minus 20 coming down, and then plus EY, but we're going to put it in terms of E here. So that's going to be 0.866 E, okay, is equal to 0. So now I'm just going to take my 20. I'm going to put it on the other side here as well. I'm going to have AY plus 0.866 E is equal to 20 pounds. Okay. Now, I still have two unknowns in this one, so I'm gonna use my moment equation to see where I'm gonna be there. So I'm gonna go up here, and I just started a new piece of paper, and the next piece of paper has another problem starting, so I don't have quite enough room, so I'm just gonna continue here. So we're gonna sum our moments around a point. We're gonna set that equal to 0, but we need to decide what point we're going to sum around, okay? So I'm thinking about summing around A, okay? So I'm gonna put my finger on A, and I'm gonna identify that right here, okay? So by doing so, I'm gonna work over to the right, and I'm gonna say, oh, I've got 20 pounds there. That's gonna cause a rotation. So I'm gonna start by 20 pounds is my force, times perpendicular distance here would be 10 inches, okay? And then the direction of rotation is going to be negative because it's clockwise, right? Go to my next force. I've got 20 pounds here causing a rotation. So 20 pounds times perpendicular distance. That's going to be 3 inches, okay? And this time it is also rotating clockwise. So that's going to be a negative out front there as well. Okay. The next one, I'm going to do my EX. EX is going to cause a rotation, and it looks like that one's going counterclockwise. Now, EX, we know, is 0.5 E. So we're going to put it in terms of its hypotenuse. So this is going to be 0.5 E times perpendicular distance. So it's the distance from here all the way down. So if we look, that's going to be a total of 8 inches. 3 plus 5 is 8. So times 8 inches. And the direction of rotation is going to be counterclockwise. So that means it's going to be positive out front. Okay. And then we have one more force. The Y component of E is also going to cause a rotation. Okay. And the magnitude is going to be 0.866 E. And then its perpendicular distance. So if we kind of push it along its line of action here, okay, we know that this total distance is 13 minus 8. So the difference here is going to be 5 inches. Okay. And then the direction of rotation is also going to be counterclockwise. So we're going to put a positive out front. Those are all of the forces that are causing rotation. So we're going to now set this equal to 0. Make sure you do that. Remember, this is an equation of equilibrium. The left side is summing the moments. and the right-hand side is setting it equal to 0. So now as we look here, this is what we're hoping for. We only have one unknown, and indeed we do. Because we put our EX and EY in terms of their hypotenuse, our only unknown here is the E. So go ahead and solve for E here and see what you come up with. And I'll do it on the side here too, and we can compare in just a minute. Let me know in the chat box or verbally if you end up getting that same value that I have here.
I got the same thing.
You did? Awesome. Thank you. Perfect. So now that we know E, we can go back in and substitute this into our some of the forces in the X and some of the forces in the Y to then solve for the AX and the AY. Okay. So just want to make sure everybody's got this. Thank you, Gabrielle. You have it too. Awesome. Okay, so now we're going to go back here. Remember, at the bottom of the page here, we had to stop because we had two unknowns. So I'm going to substitute my value for E, the 31.21, so that I can now solve for AX. So AX plus 0.5 times 31.2 pounds is equal to 20 pounds. I can multiply this together, and I am going to get that's going to be 15.6. I'm going to move it to the other side right away. So that means I'm going to have AX is equal to 20 pounds minus 15.6 pounds. Okay. So my AX will be equal to 4.4 pounds. And it's a positive value. So that means that we assumed the correct direction. Okay. So we assumed it going to the right. We ended up with a positive value to confirm that assumed direction. All right. Everybody get that as well? 4.4 for AX.
I did, yeah.
Awesome. Thank you. Thank you. Thank you. Now we're going to do that same thing. Over here, we had another E. So we're going to substitute in 31.21 here for our E. So we're going to say AY plus 0.866 times 31.21 pounds is equal to 20 pounds. So if we multiply that out, we're going to have 31. This is going to be 27.027. So I'm going to say AY. Now this is positive on this side. So I'm going to have 20 pounds minus 27.0. I'm going to say 03. That should be good. Pounds. So my AY is going to be a negative 7.03 pounds. All right. That means something to us. What that means is we assumed the incorrect direction. Okay. So we go back, well, what was the direction we assumed? We assumed AY was going up. Now, I'm going to say this again. We never leave a final answer as a negative. We never leave a final answer as a negative. The first thing we do is we make this positive, but it's a two-part solution. Then we go up here and we erase the direction, okay, of the vector that we have, and we are going to put it opposite whatever we assumed originally. I always look at your free body diagram to be sure that it is updated if you have any of these things going on, okay? Do not leave a negative value as a final answer. So our AY is magnitude of 7.03 pounds, and in the free body diagram, we have it going down, okay? Now, as we did E came out to be a positive value. So that confirmed the direction that we had here, okay? Same thing for AX. It came out a positive value. It confirmed that going to the right was a good decision. AY came out to be a negative. So that just meant, oh, that's okay. That just means I have to go opposite whatever I chose. And so again, you have to make that a positive value and change the direction of the vector to correspond. All right. So any questions on this problem? All right. So then what we're going to do is we're going to look at our next one, but I'm going to stop the recording here and we'll restart on our next problem that we're going to go over.